Welcome to this explainer. Let's boot up our high-tech 3D economic simulation to uncover the hidden, invisible costs of taxation. As we power up the system today, we're going to model exactly how money, value, and human behavior all interact in real time. Right off the bat, let's dive into this by asking the ultimate question. When governments collect revenue to fund our civilized society, who truly bears the burden? You know, it's so easy to think it's just a simple transfer of dollars from a citizen's pocket straight to the treasury. But our simulation is going to show us that the actual mechanics of taxation are far more fascinating and, honestly, a lot more costly than they appear on the surface. Just to give you a sense of scale on our digital dashboard, consider this. The U.S. government currently collects almost 30% of total income in taxes. That includes all federal, state, and local revenues. It's a massive leap from just 7% a century ago, back in 1902. As the economy has grown over the last 100 years, the government's footprint has grown even more. So we're talking about a truly massive amount of resources continuously sloshing through the system.
Act 1. The magic of surplus.
Let's start our simulation in a baseline free market, where voluntary trades generate this glowing, positive economic energy we call surplus. Let's look closely at the buyer side first. Consumer surplus is literally just the amount a buyer is willing to pay for a good minus the amount they actually pay. For example, imagine a buyer, let's call her Taylor, who desperately wants a rare Elvis Presley record. She values it at $100, but when she gets to the auction, she only pays $80. That $20 difference, that is her consumer surplus. It's pure benefit. An invisible $20 of value that she just gained simply by participating in the market. Now let's flip that around to the seller's side, known as producer surplus. If consumer surplus is all about finding a bargain, producer surplus is about making a profit. It's calculated as the amount a seller is paid for a good minus their actual cost of producing it. And this brilliantly illustrates producer surplus. Think about Andy, a painter. He bids to paint a house and gets paid $600 for the job. But his actual cost, his time, the paint, his physical effort, is only $500. By doing this job, Andy generates $100 in producer surplus. That $100 is the pure economic benefit he takes home. So, here's the crucial point. When we mash Taylor's consumer surplus and Andy's producer surplus together, we get what economists call total surplus. This represents the total economic well-being of our simulated society. In a free market without any outside interference, the invisible hand naturally allocates resources efficiently. At equilibrium, total surplus is entirely maximized, leaving both buyers and sellers as well off as they can possibly be.
Act 2. Enter the tax wedge.
Okay, let's see what happens when we introduce the government, dropping a digital tax wedge right between our buyers and our sellers. Boom! Suddenly, the natural equilibrium is totally disrupted. The price buyers pay goes up and the price sellers receive goes down. The government extracts this middle chunk to fund public services, things we all rely on, like roads, police, and public education. In our model, the government calculates its revenue by multiplying the size of the tax, which we'll call T, by the quantity of goods sold, which is Q. This creates a solid block of revenue extracted right out of the middle of the market's activity. Now, what's really interesting here is how the metrics shift. Before the tax, consumer and producer surplus were absolutely maximized. But when that tax hits, government revenue obviously rises, grabbing a big chunk of that value. However, look at the bottom line for total surplus. Consumer and producer surplus take a massive, disproportionate hit. The total surplus in the market actually falls by a significant margin.
Act 3. The phantom cost.
We've reached a pretty crazy twist in our simulation. The numbers actually don't perfectly balance out. A piece of our economy has just vanished. The total energy lost by the buyers and sellers is actually greater than the revenue the government gains. This evaporated, phantom energy is called deadweight loss. Formally, it's the fall in total surplus that results from a market distortion, like a tax. And remember, these aren't just abstract numbers moving around a spreadsheet. These are mutually beneficial trades that are literally erased from existence because the tax made them too expensive to execute.
To ground this in reality, think of Mike and May. They had this great arrangement where May would clean Mike's house for $40. Mike values the clean house at $50, and May's cost of time is $30. They both benefit, right? But then, imagine a $50 tax is imposed on cleaning providers. Suddenly, there is literally no price Mike can pay May that covers her time and that massive tax. The mutually beneficial $40 deal is abandoned. The result? Pure deadweight loss. Mike and May are worse off, and crucially, the government collects absolutely zero revenue because the trade never even happened.
As our source material brilliantly puts it, taxes cause deadweight losses because they prevent buyers and sellers from realizing some of the gains from trade. It's a tragedy, really. The market shrinks not because people don't want to trade with each other, but because the tax penalty totally alters their incentives.
Act 4. The elasticity variables.
So, does every single tax cause the exact same amount of damage? Well, no. It all depends on elasticity, which is just how drastically buyers and sellers change their behavior when prices shift. If the market is rigid or inelastic, people can't easily change their behavior, so the deadweight loss stays relatively small. But when buyers and sellers are highly flexible or elastic, they change their habits fast, and that deadweight loss just explodes in size.
Is a total behavioral chain reaction. The tax changes the price. Buyers and sellers respond to this new incentive. If elasticity is high, buyers and sellers just aggressively flee the market. They stop buying and they stop producing. And this leads us to a massive concept in supply-side economics, the Laffer curve. As the size of a tax grows larger and larger, the deadweight loss multiplies rapidly. Eventually, the tax shrinks the market so severely that the government's actual tax revenue begins to fall. Pushing taxes too high actually yields less money.
Act 5. The true cost of taxes. As we power down this simulation, it's super clear that taxation is way more complex than just moving money from a citizen's bank account to the government treasury. Every single intervention has a hidden behavioral cost. Let's run a final system diagnostic here. The true price of civilization always includes this invisible, evaporated surplus. Free markets naturally maximize well-being, but when we introduce a tax to fund our society, we inevitably create a wedge. Because of this wedge, the cost borne by citizens always exceeds what the government collects. That excess is deadweight loss, dictated by elasticity and the size of the tax, proving once and for all that higher rates definitely don't always mean higher revenues.
I want to leave you with this final thought to chew on as our explainer wraps up. If every single tax fundamentally shrinks the market and erases mutually beneficial human interactions, how can policymakers effectively fund the future without accidentally wiping out the very trades that make our society thrive?